This is Section 3 Notes, Solving Systems by Elimination. Our objectives are to solve systems of linear equations in two variables by the elimination method. We're going to use elimination to combine two equations in order to eliminate one variable. And then we will look at choosing the appropriate method for solving a linear system. Our choices will be between substitution versus elimination. Another method for solving systems of equations is elimination. Just like the substitution method, the goal of elimination is to reduce the system down to one equation with only one variable. This is accomplished by combining the two equations in the system together in such a way that one of the variables cancels out. The steps for solving by the elimination method are as follows. First, we write the system so that like terms are aligned. What this means is we will rearrange equations so that we have x in the first equation over x of a second equation, the plus or minus operations over each other, the y of the first equation over the y of the second equation, the equal signs over one another, and then the constants over one another. This is what is meant by an aligned system. So, just to recap, step 1 is to write the system so that terms are aligned. Step 2 is to eliminate one of the variables so that we can solve for the other variable. Once we get that answer for the first variable, we will plug it back in to get the numeric value for the second unknown. And once we have both values, we will write the solution as an XY pair and check that it makes both equations in the system true. Example 1 says solve the following system using the elimination method. And this is perfect for elimination method because if we look at the y, it has a -2 coefficient and a +2 coefficient. If we add these together, it is perfect for canceling out the y variable. So that's what we'll do now. We'll add the two equations together. X minus 2y equals -19 over 5x plus 2y equals 1. If we add these two equations together, we have 1x plus 5x, which is 6x. -2y and +2y give us 0y, so they cancel out. And -19 plus 1 is -18. And when we divide both sides by 6, we get x is equal to -3. Now we take that answer back to our original system. X minus 2y equals -19, and 5x plus 2y equals 1. We will replace the x variable with -3 and solve for y. And if both y's come out to be the same value, then we have confidence that we've done this correctly. So -3 minus 2y equals -19. We're going to add 3 to both sides. -2y equals -16. Y is equal to 8. So that is the solution we got from the first equation. We'll do the same thing with the second equation here. So we have 5 times -3 plus 2y equals 1. 5 times -3 is -15 plus 2y equals 1. Add 15 to both sides, and we have 2y equals 16. And when we divide by 2, we get y equals 8. And because we have a match between our y answers, we can now say the solution is x comma y equal to -3 comma 8. So here in example 2, we see that there are no coefficients that are matching and ready to cancel. So we have to do what's called an adjustment. First, we must choose which variable we would like to cancel. There's no wrong choice here. So if you choose x's, that's fine. If you choose y's, that's fine. We're just going to take the numbers out in front of those variables to help us alter the system. So let's choose to cancel out the x variables. So the coefficient of equation 2 is -3, and the coefficient of equation 1 is +2. We're looking at the x coefficients because we want to cancel the x terms. So multiply equation 1 by -3, and then we're going to multiply equation 2 by 2. This is going to give us our new system. So when we distribute this -3 throughout the equation, we get -6x minus 15y equals -78. And then when we distribute this 2 through the second equation, we get -6x minus 8y equals -50. And we see that the x's have matching coefficients, but we need them to be opposite signs. So we're going to multiply everything by -1, which just changes the sign of everything in the equation. And this will allow us to add each of the terms and successfully cancel out the x variable. So -6x and +6x will cancel. -15y and +8y gives us -7y. And -78 and +50 is -28. Divide both sides by -7, and we have y is equal to 4. And now we can plug this back into the original system and solve for x. So if both x's match when we solve for them, then we have confidence that we've done this correctly. So the top equation becomes 2x plus 20 equals 26. 2x equals, subtract 20 from both sides, and we get 6. And we have x is equal to 3. If we take the bottom equation, it becomes -3x minus 16 equals -25. Add 16 to both sides, and we have -3x equals -9. Divide both sides by -3, and we have x equals 3. We see that we have a match. And we can now say our solution is 3, 4. So here we're just going to look at 4 different problems, and we just want to identify which method should we use, the substitution method or the elimination method. So if we look at problem number 1, because the y variable is isolated, we can replace y with x plus 3 in the other equation. So that would give us 5x minus 2 times x plus 3 equals -3. And you would move on from here. So this is substitution. I will let you finish solving that. And the answer is 1,4. In problem number 2, because we see we have a negative 4y and a positive 4y, it's ready for us to combine by addition. So if we add these two equations together, we would get 10x, the y's would cancel, equals negative 10. And I'll leave this for you to finish solving. We set this up by elimination. And the solution, so you can check your answer, is negative 1,3. Problem 3, there is no variable that is isolated and there is no variable set up to cancel. So we have to choose a method that would work best. Because there's no number that can divide all three of the same equation to make it easy to solve for x or y, and that doesn't exist for either equation, I would not use substitution. I would instead use elimination. Before I can use elimination, I need to align my x and y variables. So we would first write a new system. (6x minus 5y equals negative 3), and negative 7x plus 4y equals negative 2. And now you would choose which variable you'd like to cancel. If you want to cancel the x's, you would multiply the top equation by negative 7 and the bottom equation by 6. If instead you want to cancel the y's, you would multiply the top equation by 4 and the bottom equation by negative 5. After you've done that, you would then use a negative 1 to change the sign to make the variables cancel. They have to be opposite signs, and you would solve. So the solution for number 3 is 2, 3, and this would be done by elimination. Problem 4, we see x is already solved and isolated, so anywhere I see x, I can replace x with 2 minus 3y in the other equation. This would give us 1/2 parentheses 2 minus 3y plus 4y equals negative 4. We can then distribute through the parentheses. This would give us 1 minus 3/2 plus 4y. That should be a 3/2 y plus 4y equals negative 4. And now we see we can subtract 1 from both sides. So our new equation negative 3/2 y plus 4y equals negative 5. We would change 4 to be a fraction with a denominator of 2. So we have like denominators. So 4 is the same as 8/2. And when we combine that, that gives us 5/2 y equals negative 5. And you can solve by multiplying by the reciprocal. That gives us 1y equals negative 2. I'll leave the rest for you to do. The solution is going to be 8, negative 2. And this was done by substitution. So that's the end of this lecture. Go back, watch the video again, you review it, take notes, pause as you need. The website has additional videos with additional problems. The next topic will be solving word problems using the elimination method. And then complete the Section 3 practice. Check your work with the answer key. Once you've feel confident that you're doing this correctly, move on to the Section 3 quiz.